In this video, we will discuss a steady state error concept. Steady state error is the value of error signal, that is E of S, when t tends to infinity. It is the measure of system accuracy. Steady state is the value of error signal, that is E of S, when t tends to infinity, and it is the measure of accuracy. Steady state depends nature of input, type of system, and non-linearity of system components. For example, error signal E of S is equal to R of S minus H of S into C of S. Just if you consider this closed loop transfer function, C of S in the forward, G of S in the forward path, H of S in the feedback path, it is a negative feedback, and E of S is the after comparison with R of S and H of S. See, from this diagram, I can write E of S is equal to R of S minus H of S into C of S. And we know output C of S is equal to G of S into E of S. And but in this diagram, I have written this forward path gain as C of S. Just change that one to G of S. Then error signal E of S is equal to, I can write, just substitute 2 in 1. Just substitute equation 2 in 1. E of S is equal to R of S minus H of S into C of S. That is, C of S is G of S into E of S. Substitute, simplify, multiply, we will get error signal E of S is equal to R of S divided by 1 plus G of S into R of S. Then here E of S is the error signal, E of T is the error signal in time domain, I can write. So that E of T, how to find out time domain signals from the frequency domain signal? We have to apply inverse Laplace transform. If we apply inverse Laplace transform, then I can write E of T is equal to inverse Laplace transform of E of S. That is, inverse Laplace transform of E of S is R of S divided by 1 plus G of S into R of S. Let ESS is the steady state error. We'll call this ESS as a steady state error, and I can write ESS is equal to limit t tends to infinity E of t. So steady state error is equal to limit t tends to infinity E of t. E of t is the error signal in time domain, that is in Laplace inverse Laplace transform of R of S divided by 1 plus G of S into R of S. The final value theorem of Laplace transform states that in network analysis we studied this final value theorem, initial value theorem. The final value theorem of Laplace transform states that if a Laplace transform of f of t, then limit t tends to infinity f of t is equal to limit s tends to 0 s into capital F of s. That is, limit t tends to infinity f of t is equal to limit s tends to 0 s into f of s. So the same concept will apply to this one. Error ESS is equal to limit t tends to infinity E of t is equal, I can write limit in S domain, I can write s tends to 0 s into E of s. So this limit t tends to infinity E of t is in time domain, and the limit s tends to 0 s into E of s is in S domain. So then error signal ESS is equal to limit s tends to 0 s into, what is E of s? E of s is we derived, that is R of s divided by 1 plus G of s into H of s. So finally this ESS, steady state error, is equal to limit s tends to 0 s into E of s, or s into R of s divided by 1 plus G of s into H of s. The next concept is static error constants. So that we'll discuss in the next video. Thank you.